Hey everybody, it's Nate from EXPLORIST.LIFE. I teach people how to build DIY campers, and in this video, I'm going to show you how we installed this electrical system into this Mercedes Sprinter campervan. But first, a bit of background. Waypoint Vehicles is a brand new campervan upfitter, and I've been working with them behind the scenes to design the electrical system that's going to be in this rig. Now, one of my conditions for this project was that I needed to be able to make a YouTube tutorial, a wiring diagram, and a parts list available for all of you so that you can learn something new and potentially replicate, if you wanted to, this high-end electrical system that's going to be in this high-end Sprinter campervan. Waypoint Vehicles was happy to cooperate, so I flew out to Los Angeles, and I'm ready to get this knocked out and show you how we installed it. We've only got 3 days, so let's get started. This system is going to consist of 600 amp hours of Victron SmartLithium batteries, a Victron Multiplus-II for our 120 volt loads and shore power, dual Victron Orion DC DC Chargers, and a Victron SmartSolar MPPT 130 controlling 180 watts of solar, which is expandable as needed up to 440 watts with the same charge controller. And there's a whole pile of other smaller items, bits, lugs, fuses, ferrules, heat shrink, BMSs, shunts, and all kinds of other stuff that we will cover as we get to them in the video. Which, speaking of other smaller parts, Waypoint Vehicles will also be selling a full kit of everything needed for this install, and I'll also have an itemized list of all of these parts with the wiring diagram in the blog post that accompanies this video. Link to all of that can be found in the video description below. So let me give you a rundown of approximately how all this stuff is going to be fitting into the space that we have. So we have this wood skeleton that we made ahead of time, and all of the main components, DC to DC chargers, solar charge controllers, Lynx distributor, BMSs, all that kind of stuff is going to fit on the front face right here. So it's easy to access for troubleshooting, and also so it looks nice. The batteries are going to sit right back here. And then the inverter charger is going to sit right up here on the front, mounted to the front part of this skeleton. Now, the entire thing is going to be covered up with a cover that we already have made. It's sitting over there. We'll show that to you when we're ready to put it in place at the end of the video. I just didn't want to wrestle it over here at this point. So I'm going to take this. It's removable. We're going to move it to the workbench and get started. When I made the wiring diagram for this system, I made everything to scale so that we had a pretty good idea on where everything should be for nice clean wire runs. Now I placed everything on the board in roughly the same fashion as it was on the wiring diagram. I marked all the screw holes, drilled the pilot holes for the screws, and then screwed the components to the board. So now we have all of our components fastened to the front of this panel here. We've got our dual Orion Smart 30 amp chargers for alternator charging, for solar charging right here with the MPPT 130. Lynx distributor over here. It's going to take power from the battery bank and going to go to all of these chargers here. We're also going to have power coming out of the Lynx distributor through this Smart Battery Protect toward the 12 volt breaker panel that's going to be mounted on the side of the wall inside of the van. The next step in this process is going to be connecting the Lynx distributor to these 4 devices here so that these can have power, and we are going to get started with that right now. Now all 4 of these components use 6 gauge wire with a 5/16 inch lug on one side and a ferrule on the other side. So I'm going to cut, strip, crimp, and heat shrink a ferrule onto one side of the wire, and then measure, cut, strip, crimp, and heat shrink a lug onto the other side of the wire for both the positive and negative wires. When running your wires in a system, it's really important to make sure that your wires are nice and secure. Aside from looking nice and clean, arranging your wires in an orderly fashion will make future troubleshooting easier and will also get you 30% more Instagram likes for all of your van life posts. So I just finished up wiring all of these components to the Lynx distributor. So we've got both of our DC-DC chargers. They are wired positive and negative to their own respective spots on the positive and negative bus bars inside of the Lynx distributor. Same story with the charge controller, positive and negative to positive and negative bus bars inside of the Lynx distributor. This one has a Smart Battery Protect in line. We're not going to talk about that right now. That'll be a story for towards the end of the video with the full system overview. And then lastly is this line is going out to the 12 volt breaker panel. And that also has a Smart Battery Protect. Same story as this one. Not talking about it right now. So On the inside of the Lynx distributor, we have all of these positive wires that are going to and from these various components, that's a good word, to the fuses that are on the positive bus bar inside of the Lynx distributor. So all these wires are protected from battery power that will be coming in. So that's a story as we have right now. The next thing to do is going to be connect all the communication wires to the Servo GX and the VE Bus BMS to all of these devices so that they can talk to each other. Now this part can get messy in a hurry. It's a bunch of 16 and 18 gauge signal wires and data cables going from each component to either the VE Bus BMS or the Servo GX. Now, I'm not going to be talking about what each of these individual wires do until near the end of the video. These wires play an important role on how the components talk to each other, so once we get this system up and running, that's when I'll show you how these components talk to each other via these communication wires. But for now, if you need to dive into the nitty-gritty of where each wire connects to, you should refer to the wiring diagram for this project. Now that we have all the communication wires set up for all of the components on the front panel here, we're going to move on to wiring in the Victron Multiplus-III inverter charger. So again, this is for converting the battery power into 120 volt power that we get to use for all of our standard household appliances, as well as recharging the battery bank from shore power. So what that's going to entail is we're going to take this mounting plate here, and it's going to get fastened to the wood here, and then this simply slips onto the back plate like that and is fastened to the wood here, clips on here, and then there's more screws at the bottom to fasten the bottom to keep it from jiggling around. So we're going to be doing the plate first. But before we actually mount it on there, I'm actually going to wire all the components inside of the Multiplus to where they need to go. So the 6-3 wire for the AC breaker box, as well as the connections that are going to be going back toward the battery bank. So let's get started. Wiring the power wires to the inverter simply consists of connecting the 6-gauge triplex wire to the hot, neutral, and ground terminals, black, white, and green respectively, and the positive and negative wires to the positive and negative terminals using ferrules and lugs as appropriate. The 6-gauge triplex wire is truly difficult to work with, but with the proper application of finesse and cussing, it will indeed fit. After the inverter was wired, we moved everything into the van. The box was actually not as heavy as I imagined in spite of all of the components that were mounted to it. So now that we got this box into place, we got the inverter mounted on this, we went ahead and we ran the 6-gauge triplex wire up through the wall, and the 6-gauge wire for the 12-volt branch circuits also up through the wall to not very far, but just right above where this enclosure is, because that is where this box is going to sit. And haven't seen this one on the EXPLORIST.LIFE channel yet, but this is both a 120-volt breaker panel as well as 12-volt DC breaker panel. So all the lights, fans, the refrigerator on the DC side, as well as all the outlets and everything like that on the AC side of things, as well as a nice little plug right there. This is all going to live, gotta be careful here, it's not screwed together just yet, but it's going to live right in this general vicinity. So that's why we ran that 6-3 triplex up to here, as well as the 6-gauge for the 12-volt circuits. So the next thing that I'm going to be doing is actually going to be making the connections on the battery side of things so that we can start getting some power to some of this stuff eventually. So to elaborate what I was talking about the battery connections, so the Lynx distributor and the Multiplus need to be connected to the battery, but you have to be able to combine those wires somehow, some way, right? So those are going to be combined on the shunt, and they're also going to be combined inside of the master switch. This is going to be our main fuse. Now, this is going to live right in this general area here, and this is going to connect to the positive terminal on the battery bank, and then the shunt is actually going to stay inside of the back panel of this enclosure here because we don't really need access to this really ever. So that can just stay back there. And then we'll be running these negative connections from here and these positive connections from here to all the respective devices, as well as back to the battery bank. So lots of connections to make here, lots of cutting, crimping, heat shrinking, and I'm gonna get started. So now that we have all of the 4-aught wires run to our Lynx distributor, to our chassis ground, to our equipment ground on the Multiplus, all of that good stuff, to our smart shunt and our main disconnect right here. The next step is actually going to be to connect the battery bank and wire it together and wire the battery bank to the smart shunt and to the main fuse here. And typically you're going to see wire going from battery to battery, but we are very limited in space. And so we are actually going to just be using copper bar to span from battery to battery and then use wire to go from the battery bank to the switch to the shunt. So I need to measure out this copper bar. This copper bar is a 1/4 inch by 1 inch. Measure it out to length and drill holes in their appropriate spot. And that's the next step in the process. So I'm going to get started on that. Now you can definitely use wire when going for your battery to battery connections, but we're using copper bar here because we didn't have a whole lot of space up top, and ultimately it's going to give us fewer connections, which each connection in a system is a point of failure. So that's why we're opting for copper bar instead of wire for this application. So we just finished up our copper bar here and it looks pretty nice. And these are just going to sit on top of the terminals just like this and just like this on this side. And we're just going to bolt those down, and then the wires are going to go from the battery bank here to the fuse here, and then from the battery bank here to the shunt that's mounted on the back here. Remember, it's really important to have your wires going from the battery bank to be on opposite corners of the battery bank. So that's why we're doing that. That will drain the battery bank more evenly than if you were to put it on this side, which would drain this battery first. So to get these going, we actually have to put some copper washers, got some copper washers, and they're just gonna sit on top of these terminals, because these terminals are just ever so slightly too small to account for, or too low to account for the added height for the heat shrink that is on the copper bar here. So we're going to put our 2 copper washers, our copper bar, and then bolt that down with some longer bolts than factory. And then we are going to wire that to our shunt into our master fuse. So now that the battery bank has been connected to all the components back there, you'd think we'd be ready to start, but we have a few other connections on our chargers and stuff like that we need to make. And we are going to do the alternator charging section of this, which we're not actually connecting directly to the alternator. We're actually going to be connecting to the starting battery. And then that wire is going to go under the van back to the Orion DC to DC charger. So the plan here is to connect the positive wires. So we got 2 positive wires right here that are going back to our dual Orions. And they're going to connect to this bus bar fuse holder that's actually on the side of this Sprinter, which is on most Sprinters. So if you look for the box that's on the side of the starting battery, that's where we're going to be connecting to here. Have to disassemble a bolt or undo a bolt, and then the fuse holder just pulls up and out like that, and then we should have a few fuse spaces on there that we can connect to. The negative wires, there's not a real good spot on the negative battery terminal, and I haven't found a spot I just really like to connect to, and so there's a spot at the very bottom of the under the driver's pedestal that we're going to be connecting to. It's kind of buried, but we can get to it, and it's the best place that I've found as of right now. So we're going to get started on this. This is different than the ones I've seen. Okay, so van building is all about surprises, right? So pull this bus bar out of here, and this is different than what I have seen and messed with in the past. So we have a space here for a AMI fuse, looks like that little guy right there. And that was the original plan, was to have 2 open spots right here, but we only have 1 open spot. We can't fit 2 of our wires in this particular spot. So we are going to shift gears just a little bit and not use this. And what we're going to do is we're going to do more of a universal approach, which is, I think that's a good idea anyway, to kind of teach that. And we're actually going to tie off of this particular stud right here on the top of the positive battery terminal. And we're going to use a blue C breaker. And we are going to run a positive wire from this to this. And then we're going to put 2 6-gauge wire lugs onto this that is going to feed both of these 6-gauge wires. Now, 6-gauge wire with 105-degree insulation on it is rated. This 100 amp breaker is within specs and parameters to protect both of these wires that are going back to our Orion DC DC Chargers. So let me interrupt myself really quickly and explain that just a little bit more. So I had anticipated on being able to come all the way back to that bus bar and land both positive wires inside of that bus bar, each on their own fuse. But whenever I opened it up, we only had one space available, so we had to change plans. So I opted to run a single piece of wire, 6-gauge wire, from the top of the positive battery terminal to a 100 amp breaker, and then from that 100 amp breaker, 2 wires going off to each of the Orion DC to DC chargers, which are rated at 30 amps each. So we're going to have about 60 amps going from the top of the positive battery terminal to the breaker, and then from each of the 6-gauge wires going from the breaker to each of the Orions, it's going to be 30 on each wire. Now, all of that 6-gauge wire is actually rated for about 120 amps because it is Ancor marine grade fine stranded wire with 105-degree insulation ratings on it. So it's a lot more than what you'd find in a house, which 6-gauge in a house would only be rated for about 50 amps. But since we have higher quality wire, we have a little bit more room to work with. So that 100 amp breaker protecting wire that's rated for 120 amps is good to go. Now, back to it. So that is the decision that we're making. Garrett over there was okay with it, and I think it's a great universal solution for what we're trying to accomplish. So I'm going to hook this up, put this back together, run our negative wires, and then we're going to be good to go to hook up to the Orion DC DC charger back there. So let's get started. Okay, so this is all wired up. We kind of skipped ahead a little bit, but I just want to show you approximately how this ended up working. So we connected our positive wire to this top of this stud right here, to a breaker right here, and to our dual wires that are going to our dual multipluses in the back there. Our ground connection was under the seat. And hindsight 2020, I think Garrett's going to start running the negative up under the dash to a better grounding point up front, because this was really hard to get to. So if you're trying to replicate this project, do with that information what you will. So now that all of this is connected right here and good to go, I'm going to move back and connect the other ends of these wires to the Orion DC to DC chargers in the back there. So let's go do it. Connecting the other side of the wires to the Orion TR Smart DC to DC chargers is pretty much the same thing as it was going from the Lynx distributor to the Orion units. Positive and negative wires going into the positive and negative terminals on each unit respectively. Now that the alternator charging leg of this system is completely wired up, it is time to move over to the next charging source in the system, which is going to be solar. So we've already messed with the solar up top and it's ready, but it's just disconnected and unplugged at the top so that we don't have live power coming through these 2 wires and don't get shocked, which I'm a big fan of not getting shocked. So we're going to take this wire and we're going to wire it to this disconnect switch, and from this disconnect switch into this MPPT, and through the power of movie magic, this is complete. So the entire solar leg is now wired. I will have to make the connections, just push the connections together up on the roof. We'll do that after we turn on the battery bank over there. I'll do that off camera, literally just plugging two connectors together. But now we need to move on to the last and final charging source, which is shore power. So we're going to connect the shore power connection to the inverter charger. Shore power connection on the actual outside of the van has already been connected. It's just a matter of matching up the terminals to the wires that's in the instructions with the inlet. But we're going to get started on this, and then we're almost done. Next up was connecting the 12-volt DC and 120-volt AC breaker panels into the system. Now this was the second thing that didn't go as planned, because this breaker panel is a 100% custom piece that we didn't have in hand until I was literally on the plane to the Waypoint Vehicles shop. So I had no time to pre-plan. So this part of the video was a lot of figuring out what we were working with and making it work to fit our needs, and adding neutral and negative bus bars as appropriate because they weren't a built-in part of the breaker panel. Now, don't get my frustration at this process confused with frustration in the product. Although it's a pretty pricey product and there are some silly quirks about the installation process, the unit is really, really high quality and it looks absolutely stunning once installed. Now, before we get to the system flow of power overview, I want to add a disclaimer that this is probably not a beginner-friendly installation. It's attainable, but having to deal with an external battery BMS and the related programming makes this install a solid intermediate level install. So to put this into relative terms, I would say that if you can build a computer from scratch, you probably have the skills to be able to handle this install. If you can't read and interpret user manuals, this install probably isn't for you. I do want to empower everybody to take on a big project and learn a new skill, but I also must be transparent whenever I anticipate something being too advanced. That said, let's get to the system overview. So let's get started with talking about the battery bank and how we're able to deliver power to the system. So battery bank right here consists of 3 200 amp hour 12 volt Victron SmartLithium batteries connected in parallel. So we've got parallel with the battery bank here with copper bar. And on the positive side of things, it's coming from this terminal here, feeding into the main system fuse, A&L fuse there, into a switch, and then off of the main battery disconnect switch is coming to the positive terminal of the Lynx distributor, as well as the positive terminal of the Victron Multiplus Inverter Charger. So that's how we're getting the bulk of the power to those two really important components in the system. On the negative side of things, it's coming from the opposite terminal on the opposite end of the battery bank as the positive is. It's coming out here, and it's going to the smart shunt, which is right back here. Now it's coming to this wire here is connected to the battery side of the smart shunt, and literally nothing else is connected to the battery side of the smart shunt. That's important for accurate readings. The other side is going to be connected to the chassis ground, which is actually just to the top of the wheel well right here, right to the van's metal. The other wire is going to be to the equipment ground on the back of the Multiplus, and as well as the negative terminal inside of the Multiplus. It's actually delivering power to the Multiplus. And finally, the last big 4-aught wire is going to the Lynx distributor. That's right here. And let's talk about now how the BMS functions in this system. So these batteries do not have an internal BMS. They use the Victron VE BMS, and that's what these wires are for off the side. These are tied into the internals of the battery, and they're feeding through here, back here, to the VE bus BMS. So those wires, they feed back up into here. And remember, you can check the wiring diagram for this to see how that actually looks kind of in a more laid out fashion, but they plug into here. Now the VE bus BMS is responsible for telling all of these components, whether it be internal or whether it be from these smart battery protects, when the system is allowed to charge and when it's allowed to discharge. Because with lithium batteries, they can only charge and discharge during certain temperature ranges. And if it goes too hot, you don't want them to be charged or discharged. And if it gets too cold, you don't want them to be charged or discharged. Or if there are cell imbalances or a few other parameters that are set within the batteries, you don't want them charging or discharging, or you just want them to shut down if something bad happens. So that controls that. If the batteries send the VE bus BMS a signal saying something is wrong, I'm too hot, I'm too cold, the voltage is too high, the voltage is too low, there's something else wrong, it's going to say to all of these components here to stop charging or to start charging. So that's the function at a very base level of how that works. Now, there's a lot more information to this, and the documentation on the Victron Energy website is actually pretty good for this. And it's just going to take some reading to figure out exactly how that works and how it's going to work for your own setups, or if you're trying to replicate this, but that's the basics of how that gets. So that's the battery power system. And next we're going to move on to the individual components and how we charge. 3 ways of charging, starting with alternator charging. So for the alternator charging side of this system, we have 2 Orion TR Smart 12-12-30s, which is 12 volt to 12 volt 30 amps. So since we have 2 of them, we can actually charge from the alternator at a rate of 60 amps combined between the 2 of them. So the way this is connected into the system is we have 2 separate spots inside of the Lynx distributor, both positive and negative, coming out to the positive and negative output of the Orion, so power's flowing that way. Same thing on this one, these 2 wires are on the output, positive and negative, from the Orion into the Lynx distributor. Positive and negative on both of these goes up to the starting battery up front, where it's connected to ground, as well as to the positive battery terminal via a breaker up front. So that's really how this is connected into the system. As far as how it works is, anytime the engine is on, there are parameters set inside of here that we've already programmed with the Victron Connect app. And we set our charging parameters for the proper charging parameters, but also when these turn on and turn off. Usually the default settings in the Victron Connect app work just fine for this. And how that works is, whenever your key is off on your van, your batteries are sitting at, let's call it like 13.5 volts or something like that. But when you turn the engine on, the alternator starts spinning and the voltage jumps up to 14.3, 14.5, something along those lines. And these will see that jump in voltage, and they're like, oh, okay, the battery or the motor is on and the alternator's going. So that means it's charging. So we're going to turn on here so we can charge the battery bank. Now, power does not flow in the opposite direction here. So you can't discharge your starting battery by using your house battery bank whenever these are functioning. It's just not how power works in this system. So it's a non-issue. So that is how these function in the charging side of the system. And next we're going to talk about the solar array. So the next charging source is going to be from solar. Now we're not going to show up top. I got a roof over our head right now. We are inside, so we're not really going to be able to show that particular part, but we have two 90 watt solar panels, two 90 watt ZAMP solar panels up top. They are wired in series, and they are coming down into this disconnect right here, this DC rated dual pole disconnect. And that just can get turned on or turned off, depending on if you have the rest of the system on or off, or if you just want to kill it off for maintenance purposes. And then that, out of the bottom of that, comes into the PV positive and negative, and that's supplying solar power into this MPPT charge controller. So this is the SmartSolar MPPT 130. So we're capable of handling up to 100 volts and outputting 30 amps. So even though we have 180 watts up on this roof, this charge controller, this breaker, all of these wires can handle up to 440 watts when connected to 12 volt battery bank. So power is coming out of the charge controller, and it's going down into, negative is going straight into the Lynx distributor, and positive is going into the Smart Battery Protect, and then onto the Lynx distributor. Now remember, with the BMS is telling this when to charge or when to connect versus when to disconnect based on the battery parameters. So batteries fall out of acceptable charging parameters, this will disconnect, so this can no longer charge. Now we've already set up the correct charging parameters on the Victron Connect app, which is something you really need to do before you turn on the solar breaker. We're not going to show that on this particular video. I have more info on that in the blog post, and all that information can also be found in the user manual for the charge controller and the batteries. So the next thing we want to talk about is the last charging source, which is going to be shore power. Last charging source is going to be shore power. So we've got a shore power inlet on the side of the van over there. It's a 30 amp input connected with 10-3 wire, so 10 gauge triplex wire. It's coming under the van, and it's coming into the Victron Multiplus inverter charger. Now, Victron Multiplus 3K inverter charger is both an inverter and a charger all in one with a integrated transfer switch. So it can switch automatically between powering the 120 volts via battery power and shore power. So when shore power is incoming, it passes straight through the Multiplus and powers our 120 volt circuits here, as well as charges the battery bank. So we have shore power coming in and charging the battery bank with what's not being used from the 120 volt circuits like that. So pretty straightforward on that. This is going to convert that 120 volt power into 12 volt DC power to charge the battery bank. So that's how this charges from shore power. So the next thing we need to talk about is how we get to use this power. So we've got 12 volt DC power and 120 volt AC power. So let's talk about those two usage methods. So how do we use power? So the first way is going to be 12 volt DC power. That's going to be stuff like lights, fans, USB outlets. I think there's a few other items in here that I can't think of right off the top of my head. We got a heater, so like our eSpark heater, tank sensors, gray tank dump, and a few other things like that. So how do we get that power from our battery bank to all of the various loads like that? So like I mentioned earlier, battery power, 12 volt, connected to our Lynx distributor, which is 12 volt. This wire right here, positive and negative coming through. Talk about this in a second. Positive and negative coming through under the inverter up into the 12 volt breaker panel, which is this top part right here. This is a Blue Sea 360 panel. And it's got all of our fridge, water heater, fan, USB, reading galley lights, tank level sensors, gray tank dump, tank freeze prevent, and that's it on this one. So power is coming from the 12 volt batteries to the 12 volt DC breaker box there. Now this battery protect here, its job is to not let the batteries discharge if the batteries fall out of a discharge parameter. So when it's not safe to discharge, whether that be temperature, voltage, or something else, then this will open and it will not allow power to flow to the DC breaker box, and it will not allow these loads to function in order to save the batteries in case of something bad going on with them. So that's pretty much how we've got that. Garrett is going to be installing an auxiliary Blue Sea fuse box just kind of inside here at a later date that he's going to be able to run some smaller loads, maybe some fans for this enclosure, because even though this enclosure is pretty well vented, the tolerances are technically under Victron's recommended tolerances. And whenever that happens, you may need to introduce additional power venting. Hopefully that won't be an issue, but if it is, we've already planned for that and he'll be able to add that really, really easily. So that's the 12 volt side of things. The next thing we want to talk about is how we power our 120 volt appliance. And the other way we can use 120 volt power is from our inverter. So if we're connected directly to shore power is coming through at 120 volts, and it's going through the inverter and passing right through into our 120 volt breaker panel over here to power water heater outlets, and anything else we had plugged into the outlets, like your standard household outlets. So that's how we're going to power these from shore. But the other way, and the more common way for this particular case, is going to be from battery power. So 12 volt battery power is flowing through our main fuse and main disconnect, all the way back here into the positive and negative terminals on our Victron Multiplus inverter charger. And it's going to convert that 12 volt DC power into 120 volt AC power for use for our standard household appliances. That power is going to come out through 6 gauge triplex wire into our to our AC breaker box here. Now, the reason we have 10-3 wire incoming and 6-3 wire outgoing is because of a feature in the Multiplus called Power Assist. And how that works is we have 30 amp shore power coming in, and in the event that, let's say, we're using our water heater and we have a space heater plugged into our into this circuit, and then we have an induction cooktop into this circuit, and we have an air conditioner plugged into this circuit, and all kinds of other silly stuff. We're just generally overloading what 30 amp shore power can handle. The Multiplus will actually add to shore power. So it will add up to its maximum rated capacity, which is 3 kVA, which is a little less than 3,000 watts. It will add that to shore power. So technically we could actually have a little over 50 amps coming into this breaker panel, which is why we have a 50 amp AC main breaker here and 6-3 wire going from here to here. So we give a little bit more than 30 amps, and it'll just pull that power from the battery bank. So shore power to inverter, inverter to here, and as needed, this will add power from the battery bank to the 120 volt fuse block. So that pretty much wraps up the charging sources as well as the usage of the power. And the last thing on the list to talk about is communications. Now with communication in the system, most of these components have Bluetooth capability, and they can connect to the Victron app on our phone. So if we wanted to log into the MPPT SmartSolar charge controller and change our settings or see our historical usage, same thing with the Smart Shunt, we can do the same thing. We can see our state of charge. We can see some of our historical battery or our historical power usage there. And same with a few of the other items here. Multiplus can do some similar-ish functionalities there. But in this one, we didn't want to have to rely on our phone or a tablet mounted to the wall or something like that. So we are using the Victron communication system, which is the Serbo GX, mated with the Victron Touch 50 GX. So we got Victron Serbo GX down here and the Touch 50 GX up here. So the way I like to describe this is the Serbo GX is essentially the motherboard of your computer, if you will. And all of these different components are the peripherals. So like your mouse, your keyboard, your graphics card, all that kind of stuff. All that is feeding information into this Serbo GX. And this Serbo GX is taking that data and it's feeding it up to the Touch 50 GX. Now, Touch 50 GX is a touchscreen monitor that just stays mounted up here. And it's essentially just the monitor for the motherboard, if you will. So these are connecting via VE direct cables to the SmartSolar MPPT, as well as the Smart Shunt back here. And it's also communicating with the VE bus BMS, which is controlling the Victron Multiplus inverter charger. So we can see at a glance all of our information that's up on this thing. And there's a ton of information that we can do, and it's super programmable, customizable, all that kind of stuff. And the documentation on the Victron Energy website about this particular setup is really, really extensive. And depending on how customizable you want to get with it, all of this is open source. So you can connect it to Raspberry Pi. You can do all kinds of programming depending on what your level of expertise is in that particular field. So I think that's actually all to this system. There's a lot to it. It's incredibly robust, high performance, and this is going to be a great setup for this van. So we're going to wrap things up here. We're all programmed, all wired together. This is functional. We'll be pulling this out to check solar in a little bit. I anticipate no problems there. So it's all good to go as far as that goes. So here in just a second, we're going to slide the cover back on. And as we do that, I want to give a special thanks to Waypoint Vehicles for inviting me out to shoot this tutorial and install this system in there and getting a system in front of you guys that's going to be in a high-end professional build in a very nice camper van. I also want to say a special thanks for Victron Energy for always supplying me with the information and the knowledge that I need to be able to teach you guys about camper and mobile electric systems. So as we're putting the enclosure back on the top of this thing, just sliding it right over the top, I want you guys to remember that there is a wiring diagram, there is a parts list, and there is a kit available if you wanted to replicate this exact project in your own camper van. And all of that information can be found in the video description below this video. Now, I hope you found this video helpful. And if you did, it'd be awesome if you would share it with somebody or a group who you think could use it. Hit the like button and leave any questions you got or new things you learned in the comment section below. Subscribe if you want to see more DIY camper building tutorials, and I will see you in the next video.